An object reaches its terminal velocity when the downward force of gravity is canceled by the upward force of air resistance. The forces are balanced, so there's no acceleration. When an object is in free fall, that means there's an unbalanced net force acting downwards, so the object accelerates downwards and speeds up. But air resistance acts upwards to slow the object down. It increases as the speed goes up. Eventually, when gravity is balanced out by air resistance, the object no longer accelerates. It goes at a constant speed. It's reached its terminal velocity. Here we see a simulation of an object being dropped from 12 meters with no air to the ground. We can see from the graph that the velocity increases and the acceleration stays the same for the whole trip. This time, we can change the atmosphere so there's air and see if there's any difference. We'll notice as the object falls, it eventually goes at a constant speed, terminal velocity. We can see from this graph that the velocity was increasing, but then it slowed down and eventually went at a constant speed. The acceleration dropped down to 0. Now let's look at a force diagram. This one shows the object falling without air resistance. Gravity is the unbalanced force pulling downward, so the net force points down. We can see that in this force diagram, the air resistance increases, canceling out gravity, and the net force is 0, so it goes at a constant speed.